Hello, guys. Welcome back. We are starting our next little group of lessons here, which is going to be 4.8, 6.1, and 6.2. 4.8 is all about applications of right triangle trig, and then we'll look at some real life applications as well. Okay, so we have three objectives today. The first objective is to solve real life problems involving right triangles. Okay, so how can we use our right triangles to solve problems? Our next objective is to solve real life problems involving directional bearings. So we're actually going to talk about like northwest, southwest, stuff like that. And then we're going to look at solving real life problems involving harmonic motions. So harmonic motions are things like a pendulum swinging back and forth, things like that, anything that like kind of repeats itself in that harmonic sine or cosine wave. So we're going to talk about right triangles first. So solving a right triangle. So solving a right triangle means finding the missing lengths of its sides and the measurements of its angles. So you don't have a triangle solved until you have all 6 pieces of the triangle, meaning all 3 sides and all 3 angles. Okay, so let's look at an example here. So example 1 says to solve the right triangle for all unknown sides and angles. So sometimes it might just say solve the right triangle, right? Or just solve. And again, that we have to note that that means that I'm solving for all sides and all angles. So what I tend to do is I tend to make a list of all of the angles, and then I make a list of all of the sides. And then it just kind of helps me keep it straight on what do I know, right? So like here, I already know that A is 34.2 degrees. I know that C is 90 degrees. And I know that side B is 19.4. Remember that the side is always across from the angle. So side AC is across from angle B, so this is side B. Right, so then this would be C, and this would be A. And we use those lowercase letters for sides. Okay, angle B now should be really easy to find, right? The 3 angles of a triangle add to 180. So if I do the math here and do 180 minus 90 minus 34.2, I get 55.8. So that's great. Now I have lots of different options. I need to solve for side A and side C. So I'm going to use the angle I know, which is 34.2. And I know let's solve for A, right? A is opposite, and I know B, and B is adjacent. So opposite and adjacent is tangent. So tangent of 34.2 is equal to opposite over adjacent. Because what I'm solving for is on the top, I can go ahead and just multiply by 19.4 on each side. Enter that into your calculator. Make sure you are in degrees on your calculator and not radians, right? These angles are given to us in degrees. And I get A is about 13.184. 13.184. So there's A. Okay, now the last thing I need to solve for is C. And again, I know this 19.4, and C is the hypotenuse. So adjacent and hypotenuse is cosine. So I can do the same thing, cosine of 34.2 is equal to adjacent, which is 19.4, over hypotenuse. Now here, right, I have to multiply by C. So I get C times the cosine of 34.2. Sorry, my dogs are real barky today, so. And then now I can divide, right, by the cosine of 34.2. So I get C is equal to, just to show you what I'm entering into my calculator, 19.4 divided by cosine of 34.2. And I enter all of that into my calculator, and I get C is approximately 23.456. 23.456. Now, there's other ways you could have done this, right? You could have done Pythagorean's theorem. You could have done sine using A. However, my recommendation is usually to use the information that you're given. Okay, so as I was saying, my recommendation is always to use information that's given to you, if possible, right? Only because what if you calculated A wrong, and then you use A to calculate C? Well, now C is going to be wrong as well, right? So I tend personally to prefer to use the information that they've given me, if at all possible, rather than using any information that I've found. So we have a U-try here. Okay, again, my recommendation would be to draw it. I'm a very visual person. So here we just want to solve this triangle DEF when side D is 45, angle D is 27, and angle F is 90. So go ahead and give this a try, see if you can solve the whole triangle, and then when you're ready to go over it, hit play. Okay, so here I drew the triangle DEF and I labeled everything that I knew. And then I made my list and I wrote down everything that I knew. So from here, then it kind of makes it easier for me personally to figure out what I need to find. And the first thing, angle E should be really easy to find, right? 180 minus 90 minus 27. And we should get 63 degrees here. So now that I know that, I'm going to look at what I'm given, which I'm going to use angle D, which is 27. And let's solve for E, because it's just the next one on our list. So I know opposite is 45, and I don't know adjacent. So opposite and adjacent is tangent again. So I'm going to use tangent of 27 is equal to opposite over adjacent. That doesn't look like a very neat E. There we go. Okay. So whenever your variable is on the bottom, right, I can multiply by E, divide by tangent, divide by tangent. But really what happens is these two guys switch, right? So I can just switch this and say E is equal to 45 over tangent of 27. Okay, and making sure that my calculator is in degrees, right? Because this is all given in degrees. I can enter this in and I get that E is about 88.317 centimeters. So I'm going to plug that in, 88.317 centimeters. And that's great, so perfect. We found E. A couple things. One, because I rounded that and it's not a very nice decimal, I'm probably not going to use it in my effort to find F. And two, what if we calculated it wrong? We don't want to use it then to find F because then F will be wrong. So in finding F, I want to use what I'm given again, which is the 45 and the 27. And F is the hypotenuse. So I have opposite and hypotenuse. So that's going to be sine. Right, we're just using SOHCAHTOA here. So sine of 27 is equal to opposite over hypotenuse. And again, the variable's on the bottom, so I can just switch it. So that gives me 45 over sine of 27. Enter that into my calculator, and I get the F is about 99.121 centimeters. 99.121 centimeters. And again, because it's asking me to solve the triangle, it wants all pieces. So there I have all 6 pieces of my triangle. So hopefully that is making sense. Again, just using SOHCAHTOA because these are right triangles. Let's move on. We're going to talk about angle of elevation and depression, which we have talked about before, but just as a reminder, angle of elevation is always your angle that's going up from the horizontal. Okay, you always have to have a horizontal line. Okay, so if this is my horizontal line, then the angle of elevation will be coming up from my horizontal line. And then angle of depression would be coming down from my horizontal line. Okay, so angle, go this way, right? Angle of elevation goes up, angle of depression goes down. So if I have, I guess I could draw it too, right? If I have a horizontal line, this would be an angle of elevation. And then if I have that same horizontal line, this would be depression. So it always has to go from a horizontal line. And that's just really the most important part there. And that's the part that most people forget. So let's look at example 2. It says, a safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the maximum safe rescue height? Okay, so here's my horizontal, and here's my ladder. And the angle of elevation, the maximum it can be is 72. So I'm going to call that 72. If the ladder is 110 feet, what is the maximum safety height? So what is this? So I want to know what's the highest it can go. Okay, so I'm given an angle. H is opposite of that angle. Here's my 90 degrees, right? And then 110 is the hypotenuse. So opposite and hypotenuse is sine. So I'm going to take sine of 72 is equal to opposite over hypotenuse. I want the h by itself, so I'm going to multiply both sides by 110. So I get 110 times sine of 72 equals h. Making sure I'm in degrees, I'm going to enter this into my calculator, and I get that h is about 104.616 feet. So that is the maximum safety height, is about 104.616 feet. We might go ahead and say 105 feet, just because it's easier. But that would increase the angle just slightly above 72 degrees. So hopefully that makes sense, and that's not too crazy here. Let's look at one that's a little bit harder. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. Okay, so we're just going to do this right now. Great. So this is 35. This is 200 feet. Okay, which is at the top of the building. So this right here is the building. The angle of elevation, to the bottom of the smokestack. Wow, so here's the smokestack here. Here's the smokestack. And the angle of elevation to the top of the smokestack, oh gosh, that was not a straight line, was it? Okay, well, there's the top of the smokestack, is 53 degrees. So I'm going to draw that in a different color. So this right here is 53. And let's just call this the height of, find the height of the smokestack. So this is what I'm interested in, the height of the smokestack. I'm going to call this whole thing A. Okay, so what I'm dealing with is 200 feet is adjacent to both of these angles, right? If I can find A, the whole height, And then if I can find B, the short height, right, then I can just subtract those to find H. So let's go ahead and find A. Let's find the height of the entire smokestack and the building. So A is opposite, 200 is adjacent, so it's tangent. So I'm going to do tangent of 53. Remember, I'm finding A, so it's using the whole thing, is equal to opposite over adjacent, right? Times both sides by 200, so I get 200 times tangent of 53 equals A. Then what I'm going to do is, and I'll show you how to do this on your calculator, if I have one. Okay, so what we're going to do is we're going to save this answer under A, and I'm going to show you how to do that in just 1 second. Okay, so here's my graphing calculator. Notice I'm in radians, right? So I'm going to take 200 times tangent of 53 and hit enter. So here's this number, which is great, you know, it's a number. I am going to save this under A because this is what A equals, right? So to do that, we hit this STO with the arrow button, the store, and then I'm going to go alpha, and then A is above math. So what this is going to do is it's going to take 265.409 or 4089643, right? This whole number without rounding, and it's going to save it under the letter A. So then I hit enter. So then whenever I need to use that, I just go alpha A, and it's that same number. So that makes it kind of nice, right? So I've just stored it under A. Now we're going to do the same thing. Let's find B. Well, B, I'm going to use the 35. It's still going to be tangent, but now I'm going to use the 35 degrees because it's the smaller triangle, equals opposite over adjacent. So again, 200 tangent of 35 equals B. So now I can go back to my calculator and do 200 tangent of 35, enter. So there's B, and I'm going to store it under alpha B and hit enter. Now, on the next problem, if I have to store another number under B, totally fine. You can replace B as much as you want, or you can replace A as much as you want, okay? So I'm just storing it under here for this problem, and then if I choose to store numbers for another problem under the same letters, totally fine. So here's B, right? So I have A and I have B. Well, if I look at my problem, H is going to be the difference of A and B, right? A minus B is H. So H is going to be that 200 tangent of 53 minus 200 tangent of 35. But because we have these numbers stored already, I can just do A minus B in my calculator. So let's go back to our calculator, and I'm going to do alpha A minus alpha B, hit enter, and I get 125.3, how does it want me to round? Let's just do 3 decimal places. So 125.367 feet. So H is 125.367 feet. So that is how tall the smokestack is. You didn't have to use A and B. You can use any variables you want. But just to kind of show you here how we can use our calculator to store those numbers, it's very, very helpful. All right, let's look at one more, and then we're going to do some bearings. Okay, so this says a swimming pool is 20 meters long and 12 meters wide. Okay, the bottom of the pool is slanted such that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the angle of depression of the bottom of the pool. Okay, so what we're going to do is, here's the pool. But this is kind of like the side view of the pool, okay? So this is if I was looking at, was looking at it from the side. That's kind of better, isn't it? So this is 20. I don't really need that 12, right? Because the width doesn't matter. But this is like if I cut the pool in half and I'm looking at it from the side. Okay, so at the shallow end, so here's the shallow end, it's 1.3 meters. And then what happens is the pool gets deeper and deeper and deeper, right? And then at the deep end, it's 4 meters. And I want to know what is the angle of depression. So that's theta, right? Remember, the angle of depression always goes down from a horizontal. So this is what I'm trying to find. Okay, but I know nothing about this right triangle. And again, if it helps you, you can, oh my goodness. This is what I get for trying to work with a bum knee. Okay. So like if it helps you to draw that right triangle separately, that's fine. Right? This is theta. I know that this is 20. And I actually can find this too, right? If this whole length is 4 and this guy is 1.3, then this is 2.7. So hopefully that makes sense. And I want to know what theta is. Well, 2.7 is opposite and 20 is adjacent. So opposite and adjacent is tangent. So tangent of my angle theta is equal to opposite over adjacent. Again, you want to make sure that you are in degrees here, okay? Because if you start entering tangent in with radians, you're going to get the wrong answer. Okay, how do I get rid of the tangent? How do I get theta by itself? I have to take the tangent inverse of both sides. Okay, so that gets me that theta is equal to the tangent inverse of 2.7 over 20. And again, as long as you're in degrees, this should be fairly quick to enter into your calculator. Tangent inverse is above tangent, so I'm going to go second tangent inverse, and then 2.7 divided by 20. So I get 7.688. So theta is about 7.688 degrees. So that is the angle of depression of the pool to go from the shallow end to the deep end. Okay, hopefully we're feeling okay. What we're going to do next is we're going to look at bearings, which is using our directions. Okay, so bearings, like I said, has everything to do with direction, okay? So the bearings from point O is always going to be the origin, okay, of our compass, our north, south, east, west. So the bearing from the origin to any point is the acute angle from the north-south line. So it's the acute angle from the north-south line. So right here's my north-south line. And so there's east-west. If I have an angle going out, okay, it's always going to be from the north-south line. So do you start at north and go east? Or do you start at north and go west? Do you start at south and go east, or south and west, right? Lots of different options. Well, really 4 different options. Okay, so I'm going to kind of go through these kind of slowly, and hopefully it makes sense for us. So the bearing from O to A. So here's A. And so Remember, you always start from the north-south line. So A is on the north side, so I would start north, right? And I would go east to get to A. So how we write this is it's north, because you start at north. And then I have to figure out what this is. Well, this angle, right? I know that north to east is 90, and I know that this is 32. So that tells me that this guy is 58. Okay, so I started at the north, then I went 58 degrees east. So I started north, and then I go 58 degrees east, and that will get me to A. And so that's what that's saying. Okay, is hey, you start north, and then you go 58 degrees to the east, and you will get to that line, OA. All right, and that's it. That's the bearing. So here, we can leave this. That's probably good to leave that. Okay, now the bearing from O to B. Okay, so here's B. I start at the north, and I go 24 degrees west. So that's 24 degrees west. And that's my bearing. Okay. O to C. So where's C? Here's C. I start south, right? I start on the south axis. And then this is 75. So that tells me that this guy right here is 15. Right, so small. So I start at south, and then I go 15 degrees west. And then the last one is D, right? I start at south, and I go 25 degrees east. So your first coordinate is always going to be north or south because you always start at the north-south axis. Okay, then you're going to say how far you go and then in what direction, right? You start at north, you go 35 degrees west or east, right? So you have to give that direction. And what this allows us to do is it allows us to solve some real world problems by just giving us the bearings. So what we're going to look at, we're actually going to skip example 5. It's missing some information, so we can't really do it. It's funny, there we go. So we're going to do the you try together then instead. Okay, so this says a ship leaves port with a bearing of south 40 degrees west. After traveling 7 miles, the ship turns 90 degrees and travels on a bearing of north 50 degrees west for 11 miles. At what time is the bearing? Oh, at that time, what is the bearing of the ship from the port? Okay, so let's start with, I'm going to draw my north-south line. I have to have those north-south lines. And I'm going to call this my port. Okay? Now, the ship leaves at starts at south 40 degrees west. So the ship goes this direction, where this right here is 40 degrees. And it travels along there for 7 miles. Okay. Then the ship turns 90 degrees. So, like that, let's say. And again, if I draw that north-south, it's traveling at north 50 degrees west. So that means that this right here is 50 because I start at north and I go 50 degrees west. And it travels along there for 11 miles. Okay. Then it's saying at that time, what is the bearing of the ship from port? So if I draw a line, holy moly, you guys. Oh my gosh, why can't I draw a straight line? Okay. Okay, that's as close as I got. Okay. So I want to know what is the bearing from port. So I want to know what is this guy. And I'm going to just call it alpha. Okay. And then I don't know what this is either, but that's okay. And I do know that this is 90 degrees. So I have a right triangle. So that's very helpful, right? Because if I have a right triangle, I can solve for theta. I have opposite and I have adjacent. So I can solve for theta. And if I know theta, I can solve for alpha because these three angles make up 180 degrees. So let's start with finding what theta is. So because I have opposite and adjacent, I'm going to use tangent. So tangent of theta equals opposite over adjacent. Take the inverse. So I have tangent inverse of 11 over 7. And I get that theta is approximately 57.529 degrees. Okay. So now I know that alpha plus 40 plus 57.529 equals 180. So I can easily solve this for alpha, and I get that alpha is approximately, I'm still using approximately because I rounded this 57.529. So I have 82.471 degrees. So that's great, but it wants the bearing, right? So I have to actually write it as a bearing. So would I start from the north or the south? Hopefully we see, right, if I drew a horizontal line, it would be on the north side. So we're going to start on the north. And I go 82.471 degrees in the west direction. So there is my bearing. So just using that, the bearing is just another way to just tell you what the angle is looking like. Okay, so the last thing we're going to look at is simple harmonic motion. Again, these are motions that can be modeled with a sine wave. So like the example here is a pendulum, or the example we're going to look at is a spring going up and down, things like that. If the situation is drawn on a coordinate plane, it will look like either sine or cosine. Notice here the equations are exactly the same. The only difference is that some of the variables are different, right? We have omega instead of a b, and then our variable is t. So the motion has amplitude. The amplitude is still the absolute value of a. It's still the same thing. The period is given by, again, since we're using sine and cosine, the period of sine and cosine is 2 pi divided by whatever's in front of t, which in this case is omega. Okay, and again, it's a lowercase omega. And then this is usually denoted by time, right? Like it'll give you 20 seconds. It takes 20 seconds for the pendulum to go one way and then back the other, or whatever. And then the frequency is given by the reciprocal of that. So we take the absolute value of omega and divide it by 2 pi. And that's how many cycles occur in 1 second or 1 minute or whatever. So we use a lowercase f for that. Okay, so this is the keynote right here, is that the period is the amount of time it takes to go through one complete cycle. So like on a pendulum to go one way and back, like when it ends back there, how long is that? That's the period. And then the frequency is how how many cycles does it go through in 1 second or in 1 minute or whatever the 1 unit of time is. And then something that really helps here is just noting that the period is 1 over the frequency, right? They're reciprocals of each other, which means the frequency is 1 over the period. So if you know the period, you can find the frequency by just taking the reciprocal of it. So let's look at our example. It's a lot of reading, so let's read it through it first and then see kind of what we're looking at here. So it says a ball is bobbing up and down on the end of a spring. Suppose that 10 centimeters is the maximum distance the ball moves vertically upward or downward from its equilibrium. Suppose further that the time it takes for the ball to move from its maximum displacement above zero to its maximum displacement below zero and back again is 4 seconds. Assuming the ideal conditions of perfect elasticity and no friction or air resistance, the ball would continue to move up and down in a uniform and regular manner. So we are not, so what I say is like we're in math world, right? Where it keeps going forever and ever and ever. Where we know in the real world, eventually it will stop. Write the equation for the simple harmonic motion of the ball. Assume that d equals 0 when t equals 0. What is the frequency of this motion? Okay, lots of information. So let's kind of go back. I know that 10 centimeters is the maximum and minimum that it goes. So I'm going to kind of draw a diagram here. So I know that the highest it goes is 10 and the lowest it goes is negative 10. Okay. I know that the maximum or the time it takes to go from up to down and back again is 4 seconds right here. T is 4 seconds. So that is the period. So I know the period is 4 seconds. So, and then also here, assume that D is 0 when T is 0. So it's starting at 0. So that tells me that I'm using sine of x, right, instead of cosine. So sine, I know it goes up and then back down and then back. And I know that that whole thing takes 4 seconds. Okay. And that's kind of all the information it was given, right? So let's look. I'm using the equation from up above, that D is equal to I'm using the sine omega t. I know I'm using sine because I'm starting at 0. Okay, so A here is my amplitude. Well, my amplitude, I go from 10 to negative 10, so my amplitude is 10. Okay. I know that let's plug it in, sorry. 10. All right. I know that the period is 4 seconds, right? So the period is always 2 pi divided by omega, and I know that that is 4. So I'm going to go ahead and solve this for W, okay, for omega. Multiply by omega, and I get 2 pi is equal to 4 omega divided by 4, divided by 4, and I get pi over 2 is equal to omega. So that tells me that this is pi over 2 t. So there's the equation. All right, write the equation. And then the next thing is, what is the frequency? Well, frequency is equal to 1 over time. So I know that there is 1 cycle in 4 seconds, right? It goes 1 full cycle in 4 seconds. And I want to know how many cycles does it do in 1 second? So I just divide. So I just divide and I get 1/4 cycle per second. It goes 1/4 of a cycle per second, which so the frequency is 1/4, and then we use hertz. Make a note of this. This is hertz. Is the unit for frequency. So that's the unit for frequency. So the frequency of this motion is 1/4 hertz. It goes 1/4 of a cycle every second. Okay. Last example that we're going to do is kind of going the opposite, like I'm given the equation. So let's find all of the stuff. A says, given the equation for simple harmonic motion, d equals 6 cosine 3 pi over 4t, find the maximum displacement. Well, the maximum, that's just my amplitude, right? How far up does it go? How far down does it go? And so my amplitude here is 6. So A equals 6. Then it says find the frequency. Okay, well, the frequency was omega divided by 2 pi. In this case, my omega is 3 pi over 4 divided by 2 pi. So what I'm going to do, I'm going to write this next to each other. So 3 pi over 4 divided by 2 pi. I can make this 2 pi over 1. So then I can copy dot flip. So 3 pi over 4, this is just basic fractions, right? Copy dot flip, and then I multiply straight across. So 3 pi over 8 pi. The pi's cancel, and I get 3 over 8. So it's 3 cycles in 8 units of time. I don't know what the units of time is because it doesn't give me, right? It doesn't tell me whether it's seconds or minutes or hours or whatever. But I know that this harmonic motion goes 3 full cycles in 8 units of time. Okay, and then we want to find the value of d when t is 4. So I'm just going to plug in 4. So d is equal to 6 cosine of 3 pi over 4 times 4. Well, the 4's can cancel. So I just get 6 cosine of 3 pi. Okay, we're going to use the unit circle here. Cosine of 3 pi. So here's 0, right? 1 pi, 2 pi, 3 pi. The coordinate here is -1 comma 0, so the cosine is -1. So this is 6 times -1, so I just get -6. So see, we can use the unit circle. We don't need a calculator to calculate that. And then the last one says the least positive value of t for which d is 0. Okay, so I want to enter 0 here. 6 cosine of 3 pi over 4t. Okay, so in order for this whole thing to be 0, right, I can divide by 6, and I get 0 equals cosine of 3 pi over 4 times t. Okay, so that means that the cosine, right, the x value of whatever angle this is has to be 0. So if we look at the unit circle, here at 0, my cosine is 1, right? And then here at pi over 2, I have 0, 1. So this is the smallest value when my x coordinate is 0, is at pi over 2. So that tells me that 3 pi over 4 times t has to equal pi over 2. Whatever's in that parenthesis has to be pi over 2. And I'm going to solve for t. So I'm going to divide by 3 pi over 4. So pi over 2 divided by 3 pi over 4. Again, more fraction work. We have to copy dot flip. So pi over 2 times 4 over 3 pi. And I get 4 pi over 6 pi. The pi's cancel, and I get 2/3. So that is the smallest value of t that I can have. That will get me 0 as an output. So t is equal to 2/3. Okay, hopefully that makes sense, you guys. If you have any questions, again, always make sure that you reach out for help if you need anything. You guys know how to find me. You know how to get a hold of me. Let me know. Good luck, and I'll see you soon.